In probability chapter, we have learned what is probability, how to calculate probability, and we also learned about the addition theorem of the probability. In addition theorem, we have learned that whenever we are getting a word or, then we have to use the plus. It means if probability of A or B is over there, then we have to use probability of A plus probability of B. Similarly, if we are having probability A union B, so the union is also treated as plus. Already we have discussed that whenever you get or, you should use plus, or whenever you get union, there also you should use plus. So the probability of A or B or C will be probability of A plus probability of B plus probability of C. Similarly, probability of A union B union C, the formula for that is probability of A plus probability of B plus probability of C. But in today's video, we will discuss the modified form of the addition theorem of the probability. Sometimes the question are in this form in which there is a mutually exclusive events are over there. Like if probability of one occurrence are adding into both, then we have to use the modified form of the addition theorem. So firstly we will discuss what is the modified form of the addition theorem. Then we will discuss that probability of A or B, that is probability of A plus probability of B minus probability of A and B. Probability of A or B or C, that is probability of A plus probability of B plus probability of C minus probability of A and B minus probability of B and C minus probability of C and A and plus probability of A and B and C. So this is called, whenever we are using or word, we have to use plus, but this is the modified form of the addition theorem. It means if events are mutually exclusive, then we have to use this formula, that is probability of A or B, that is probability of A plus probability of B minus probability of A and B. If three event is over there, probability of A or probability of B or probability of C, then probability of A plus probability of B plus probability of C minus probability of A and B minus probability of B and C and minus probability of C and A plus probability of A and B and C. So we can use here union also. So in union case, that the formula will be same, probability of A plus B minus probability of A and B. Probability of A union B union C is over there. So union is equal to plus is equal to or. Okay. So we are having probability of A plus probability of B minus probability of A and B. If formula for the probability of A union B union C, so the probability of A plus probability of B plus probability of C minus probability of A and B minus probability of B and C minus probability of C and A plus probability of A and B and C. How to solve this modified form of the addition theorem? The very first, we are having some question. In that question you will learn how we can use. Suppose in a pack of 52 cards, first question we are doing. From a pack of 52 cards, one card drawn at a random. What is the probability that it is a card of heart or it is a king? So the probability of getting heart, that is 13 upon 52, because in card 13 cards related to heart. What the very first, you could again listen the question. From a pack of 52 cards, one card drawn at a random. What is the probability that the selected card are a card of heart or a king? So then probability of getting king, that is 4 king is over there, 3 upon 52. So the both is over there. The first one is probability of getting hurt, that is 13 upon 52, because in card there are 13 heart card is over there. Second, there are 4 king, but the problem is this: king of heart is include here also and he'll include here also. So both events are mutually exclusive. So then we have to use the modified form of the probability. Listen, when we are asking a card of heart, so there are 13 card of heart in 52 pack of in a pack of 52 cards. So there is 13 upon 52. In this also the king of heart is available. Okay. Now we are taking the king. So there are 4 king in a pack of 52 cards. So that is 4 upon 52. But one is common. King of heart is here also, include here also. So common probability, that is king of heart, that is 1 upon 52. Because king of heart include here also or here also. So for getting probability of A union B, that is called probability of A plus probability of B minus probability of A and B. We are having the minus probability of A and B. So this will be 13 divided by 52 plus 4 divided by 52 minus 1 divided by 52. So this one card are included in this also and in this also. So this include in both. So one time we will subtract it, because 2 times 1 by 52 is adding. So one times we have subtract it. So there is 52. 13 plus 4 minus 1, that is 17 minus 1 upon 52. So answer will be 16 upon 52. So in this form, the modified form of the addition theorem we use. We are having some more question related to this. From a pack of 52 card, one card is drawn at a random. From a pack of 52 card, one card drawn at a random, what is the probability it will be? A black color card or a queen. From a pack of 52 card, one card drawn at a random, what will be the probability? It's a black color card. So for getting black color card, the probability is 26 upon 52, because spade is black. 13 cards are spade. Sorry, club is black and spade is also black. So 13 card related to spade. So total black card in a pack of 52 cards, there are 26 black cards over there, and total queen. So queen is 4 upon 52. But queen of spade and queen of club both include in this also. It means हुक्म का जो बेगम और चिड़ी का बेगम है वो इसमें भी है और इसमें भी है. So common probability, that is A and B, that is 2 upon 52. So having probability of A union B, that is called probability of A plus probability of B minus probability of A and B. So we will having 26 divided by 52 plus 4 divided by 52 minus 2 divided by 52. So that will be 30 minus 2 upon 52. So answer will be 28 by 52. That is 14 upon 26. That is 7 upon 13. So in this form, the modified form of the addition theorem we use. We having, this is second question. In this question we have calculated from a pack of 52 card, one card is drawn at a random. What is the probability of getting a black card or a queen? So if events are mutually exclusive, it means the queen of club and spade include in this also, and queen of spade and club include in this also. So 2 times it is adding, so 1 times we have deducted this. Now come to the another. 1 to 30 numbers are over there. One number choose at a random. What is a probability? It will be divisible with 2, 3 and 5. The probability of division with 2, 3 and 5. So if you go to 1 to 30, divide 1 to 30, there are 15 number, these are divisible with 2. Okay. So probability of getting divisible with 2, that is 15 upon 30. Because 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28 and 30. There are 15 numbers which is divisible with 2. Probability of getting divisible with 3, that is 10 upon 30, that is 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. And probability of getting divisible with 5, that is 6 upon 30. 5, then 10, then 15, then 20, then 25 and 30. So the divisible with 2 is 15 upon 30. How we calculate it? 30 divided by 2, that is 15. Divisible with 3, 30 divided by 3, that is 10. So I have 10. 30 divided by 5, that is 6. Now divisible with 2 and 3. Some number are divisible with 2 and 3 also. Divisible with 2 and 3. So there are 6 number divisible with both. 12 number divisible with both. 18 number divisible with both. 24 and 30. There are 5 number. In these 5 number, both 5 number are divisible with 6 and 3 also. So that will be having 5 upon 30. For getting this, we are having 30 divided by 2 multiply 3, that is 6. So that is 5. Now divisible with 3 and 5. Divisible with 3 and 5 up to 1 to 30. How many numbers are divisible with 3 and 5? So there are 2 number, 15 and 30, divisible with 5. So this will be 3 and 5, that is 2 upon 30. Or we have 3 and 5, that is 2 upon 30. How we calculate? 5 3 ja 15. So 30 divided by 15, that is 2. Now divisible with 5 and 2. 5 and 2, 10, 20, 30. All number have divisible with 2 also, divisible with 5 also. So that is 3 upon 30. How we calculate it? 30 divided 5 to 10. That is 3. Okay. Now come to the point. Now one more we have to calculate, that is divisible with 2 and 3 and 5. So 30 number, 5 3 ja 15, 2 ja 30. 30 divided by 30. So there is one number which is divisible with 2 also, with divisible with 3 also, with divisible with 5 also. So that will be 1 upon 30. So the probability of A union B union C, that is probability of A plus probability of B plus probability of C minus probability of A and B minus probability of B and C minus probability of C and A plus probability of A and B and C. So having probability, that is 15 upon 30. For getting 10 upon 30, 6 upon 30 minus 5 upon 30, probability of A and B, probability of 3 and 5, 2 upon 30, minus probability of 3 upon 30, plus probability of 1 upon 30, because last one is plus, that is this 2 and 3 and 5. So we are having 30 is LCM, 15 plus 10 plus 6 minus 5 minus 2 minus 3 plus 1. So 10 to 10 cancel, so then 15 plus 16, 15 plus 6, 21 plus 1, that is 22 upon 30. So we are having 15 plus 10 plus 6 sorry, minus 10 plus 1, 31 minus 10 plus 1, so 22 upon 30, that is 11 upon 15. So in this form we can calculate the addition form of the multiplication theorem. Here we use this formula because 3 event was over there. 1 to 30 we are to calculate the divisible number with 2 and 3 and 5. So 30 divided by 2, that is 15. 30 divided by 3, that is 10. 30 divided by 5, that is 6. 2 and 3 multiplication 6. So 30 divided by 6, that is 5. 3 and 5 multiplication is 15. So 30 divided by 15, that is 2. And 2 and 5 multiplication of 2 and 5, that is 10. So 30 divided by 10 is 3 upon 13. And all multiplication is 30. So 30 divided by 30, that is 1. So in this form you can calculate, that is called addition form of the multiplication theorem. One more question related to this, so we will having the perfection on this topic. Suppose that's one question we are having. From 1 to 100 number is over there. How many number will be divisible with 5, 7 and 11? 1 to 100 number is over there. How many number will divisible with 5, 7 and 11? For getting divisible with 5, so we will 100 divided by 5, that is 20 divided by 100. Divisible with 7, so what we will do? 100 divided by 7, that is 14.28. So 14 upon 100. What we have done? 100 divided by 7, that is 14.28. So 14 is over there. That is 7, 14, 21, 28, 35, 42, 49, etc. Okay. Now divisible with 11. If we are to calculate the divisible with 11, so probability of division with 11, that is 100 divided by 11, that is 9 upon 100. Now probability of 5 and 7, so 35 and 7, 70, both have divisible with 5 and 7. So 7 5 ja 35. So 100 divided by 35, so 2 point something will be over there. So 2 divided by 100. Now divisible with 7 and 11, so only 77 number is over there, which is divisible with 7 and 100, so 100, 1 upon 100. Now divisible with 11 and 5, so one number only 55 is divisible with both number, that is 111. Now divisible with 5 and 7 and 11, there is no number, nothing is number which is divisible with both 5 plus 7 plus 11, because 5 multiply 7 multiply 11 is 385. So that is 0 upon 100. So in this manner, from 1 to 100 we have calculated that divisible with 5 is 20 upon 100, divisible with 7 is 14 upon 100, divisible with 11 is 9 upon 100, divisible with 5 and 7, that is 2 upon 100, divisible with 7 and 11, that is 1 upon 100, divisible with 11 and 5, that is 1 upon 100, divisible with 5 and 7 and 11, that is 0 upon 100. So for getting probability of A union B union C, that is probability of A plus probability of B plus probability of C minus probability of A and B minus probability of B and C minus probability of C and A plus probability of A and B and C. So we will having 20 divided by 100 plus 14 divided by 100 plus 9 divided by 100 minus 2 divided by 100 minus 1 divided by 100 minus 1 divided by 100 plus 0 divided by 100. So LCM will be 100. So 20 plus 14 plus 9 minus 2 minus 1 minus 1 plus 0. So the addition will be 20 plus 14 plus 9 minus 4. So that is 39 upon 100. So the answer will be 39 divided by 100. So in this form, we can use the addition form of the modified form of the addition form. It means if events are mutually exclusive, it means the event are having a hand in both condition. Suppose we are saying that from a pack of 52 card, one card drawn at a random, what is the probability that there will be heart card, there will be king. So in heart card also the king is included, and in king also the king of heart is included. So in such kind of the condition, we have to use this modified form of the addition theorem. One more question related to this we are having. A pair of dice thrown, what is the probability that the sum of digit will be 7, non 7, non 11 we are having. From a pack of 52 card, one card drawn at a random, what is the probability that will be a figure card or a card of spade? From a pack of 52 card, this is fifth question, one card drawn at random, what is the probability that will be a card of figure, second card of spade. So card of figure have in queen have figure, jack have figure and king have figure. So 12 card is over there and card of spade is 13. So probability of A, that is 12 upon 52. Probability of B, that is 13 upon 52. But 3 cards are included in both, like jack, queen and king of spade are included in this also and in card of figure also. So the common probability, that is probability of A and B, that is 3 upon 52. So probability of A union B, that is called probability of A plus probability of B minus probability of A and B. So we'll having 12 upon 52 plus 13 upon 52 minus 3 upon 52. So we having 52, 12 plus 13 minus 3. So that is called 22 upon 52. So in answer will be 11 upon 26. So in this form, we can having the addition form of the modified form of the addition theorem. So I think with the help of this video, you may be learn how to calculate that addition form, the modified form of the addition theorem. We will having one more video related to this. So we will having more command on modified form of the addition theorem. Thank you.